Assalamu alaikum, dear students. Today we are going to solve an exercise 10.3 of the chapter Permutation Combination from this book. You can understand the basics of permutation combination. And in this video, I'll try to explain in such a way so that you'll be able to understand the question, how to go through the questions, how to analyze the logic and find out the answers in shortest time possible. So let's start. Before solving exercise 10.3, definitely you need to solve exercise 10.1 and 10.2. Solve all the maths there, exercise 10.1 and 10.2, then come to 10.3. All right. So at first question, without using calculator, find the value of each of the following using the NPR. Key on your calculator to check. You already know about the formula if you go through exercise 10.1 and 10.2. The formula is NPR. Here n is, if you simplify it, it will be n factorial divided by n minus r factorial. So you have to use this formula. So the first one is 8p5. So it will be 8 factorial divided by 8 minus 5 factorial. You cannot use the calculator. So 8 factorial divided by 3 factorial. Now 8 factorial can be written as 8 into 7 into 6 into 5 into 4 into 3 factorial. And there is also 3 factorial in the denominator position. So we can cancel them. Now you can use the calculator. So the answer is going to be 6720. You just have to multiply these numbers. Okay. Next B, 6p4. So 6 factorial divided by 6 minus 4 factorial. So 6 factorial can be broken like 6 into 5 into 4 into 3 into 2 factorial. So you can cancel 2 factorial and 2 factorial. So the answer is going to be 360. In this way you can solve it. So I'm explaining these things with a more simple example, like say for example 4p2. You cannot use the calculator. So 4 factorial divided by 2 divided by 4 minus 2 factorial. So 4 factorial divided by 2 factorial. Here 4 factorial can be, what does 4 factorial means? 4 factorial means the product of 4 into 3 into 2 into 1. 5 factorial means 5 into 4 into 3 into 2 into 1. All right, so 4 factorial can be written as 4 into 3 into 2 into 1. And there is already 2 factorial at the denominator position. Now 2 into 1. 2 into 1, it can be written as 2 factorial. So that's why we won't go far to 1. We will go beyond to 2. We will keep it up to 2 factorial. Why? Because so that we can cancel 2 factorial from the numerator position and denominator position. So the answer is going to be 12. Okay, so that's what I'm doing for solving all the questions from question 1. In A, 8 factorial. So 8 into 7 into 6 into 5 into 4 into 3 factorial. Why? Because there is already a 3 factorial as denominator. Now in B, 6p4, I have stopped at 2 factorial. Why? Because there is a 2 factorial at the denominator position. So we can cancel them out, right? So that's what you have to follow if you are solving this without using the calculator. Let's do the C and D. So 11 factorial divided by 11 minus 8 factorial. 3 factorial, which can be written as if we solve it, the answer is gonna be 6652800. Okay. Now in case of D, 7p7, which is 7 factorial divided by 7 minus 7 factorial. Now always remember 0 factorial is 1. 0 factorial is 1. So 7 factorial is going to be 7 into 6 into 5 into 4 into 3 into 2 into 1. If you use the calculator, the answer is 5040. Okay, so this is a very simple question. It's not going to come in your O-level exam, definitely, but you need to understand the process for solving more difficult questions. Okay, so now we're going to solve the next questions, the word problems. Find the number of different ways that 4 books chosen from 6 books be arranged on a shelf. You have total 6 books, but in your shelf you can keep 4 books. In how many ways you can do it? The answer is going to be simply 6p4. Now, why is that? Why it's going to be 6p4? This is because if you want to solve this question, if you want to solve the problem manually, it's going to take a lot of time. To make the process simple, we can use this formula, this method of permutation, to find out the results. Why it will require a lot of time if you want to solve the questions manually? Because we have 6 books. So for example, the books are A, B, C, D, E, F. Now what you have to do, you have to pick 4 books from here and you need to arrange them on a shelf. So you can pick this 4 book, A, B, C, D. So that can be an arrangement. So for example, arrangement number 1. If you shuffle the book, just change the position of book B and A. So that's going to be another arrangement. You can make 4 factorial arrangement. That means 4 into 3 into 2 into 1. 24 arrangements just by using books A, B, C, D from the 6th book. And again, if you pick book C, D, E, F, that's a different arrangement. And here also you can make 4 factorial arrangements. So in this way, the number is going to be huge. The actual answer is 360. So there are plenty of options. By picking only 4 books from the 6 books, there are 360 different ways in which you can arrange them. Question 3. How many different 5-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6, 7, and 9 if no digit can be repeated? So that's simple. 9 digits are available and we have to pick 5 digits. So 9p5, it's going to be 15,100. So that's quite simple. In question 4, there are 8 competitors in a long jump competition. In how many different ways can the first, second, and third prizes be awarded? Now, this is quite easy as well. Think about it. Say, for example, there are 8 competitors, A, B, C, D, E, F, G, H. Now, within this 8 competitor, we can give first, second, and third prize. So think about it. So for example, A can got the first prize, E can got the second prize, H can got the third prize. And we can also shuffle this prizes to the persons, different persons. Like at other time, E can get the first prize, A can get the second prize, and say for example, C is getting the third prize. Okay, so that means it's also related to arrangement. Okay, it's also related to arrangement. So that's why we have to use permutation. 8 competitors are available and we can distribute 3 prizes, first, second, and third. So the total possible ways will be 8p3. 8p3, which is 336. Right. So I think you have understood. So let's move on to question 5. In question 5, find how many different four digit numbers greater than 4,000. So you can say that as we are proceeding in this particular exercise, the questions are getting difficult. I mean, they're giving us more condition. You have to consider multiple things for solving the questions as we are moving forward in the exercise. And to be honest, this question 5, 6, 7, 8, this type of question you will get in your exam. You're not going to get questions easier than this. The questions are going to be harder than that, but not easier than the questions we're going to solve in question 5, 6, 7. And also, one of the most important thing when you are taking the course statistics in Cambridge AS or A2 or Edexcel AS or A2, when you are taking the S1, you have to again go through this permutation combination, and those questions are going to be really hard, comparatively much more difficult than whatever you were doing in O level. So you have to keep that in your consideration while solving this exercise. You need to learn this topic at your fullest so that you don't face much difficulty in A level, in AS or A2, whenever you are going to take S1. So be careful. In question 5, we can see that there are more conditions. Find how many different 4-digit numbers greater than 4,000 can be formed using the digits 1, 2, 3, 4, 5, 6, and 7 if no digit can be used more than once. So we can use one digit only once. Now, 4-digit numbers, and it has to be greater than 4,000. Now, if the question was like that, how many 4-digit numbers you can make use these digits? Then the answer was very simple, 7p4. But here, there is another condition which is added. The 4-digit numbers has to be greater than 4,000. Greater than 4,000. So think about it. For 4-digit number, the first digit has to be greater than 3. I mean, it has to be 4 or greater than 4. So how many digits are here that is greater than 4? That is 4. We are having 4 digits. 1, 2, 3, 4. And we have to pick one of them at the first position of the number. So in how many ways we can do it? We can do it in 4C1 or 4P1 ways. Now it's the same thing, because when you were choosing one substance from 4 substance, so the value is going to be 4C1 or 4P1. The value is same. So let's consider it as 4P1. So the first digit has to be 4 or greater than 4. And in how many ways we can do it? 4P1. Now, how many positions left? 3 positions left. And we have already used one digit here. So we are left with 6 digits. And from that 6 digit, we can pick 3 digits because we have 3 positions left. So in how many ways we can do it? We can do it in 6p3. Be careful. It has to be a 4-digit number. It has to be a 4-digit number. So the first digit has to be 4 or greater than 4. So we can pick one digit from 4 digits. 4 digits that are 4, 5, 6, 7. And we are left with 3 positions, and we have 6 digits available because within the 7 digits, we have already used one digit here. So we are left with 6 digits, and we can pick 3. In how many ways we can do it? We can do it in 6p3 ways. So the answer is going to be 4 into 6p3. If you solve it, the value will be 480. Use the calculator. So you'll get your answer. Okay, fine. So let's move on to question 6. Now here, in question 6, there are more conditions. And what is that? Find how many even numbers. Now we have to find out even numbers between 5,000 and 6,000, which can be formed from the digits 2, 4, 5, 7, 8, if no digit can be used more than once. So now we have to find out even numbers, but that even numbers have to be in between 5,000 and 6,000. So you already know about even numbers. So that means the last digit has to be even number. All right. So now the number has to be within 5,000 and 6,000. 5 can be used as the first digit because the number has to be in between 5,000 and 6,000. So we can put only 5 as the first digit. Now we are left with how many digits? 4 digits. That is, we're left with 2, 4, 7, 8. Now think about it. The number has to be an even number. So in the fourth position, we can either use 2, 4, or 8. So in fourth position, we have to put an even number. And how many even numbers we are having here? We are having here 3 even numbers. And from that, we have to pick one number. So 3 numbers available, we have to pick one number. In how many ways we can do it? We can do it in 3p1 ways. So first position is done. Last position, last digit is done. We're left with 2 positions in between. And we are also left with how many numbers? 3 numbers, because there were total 5 numbers and we have already used 2 numbers, one for first position, another for last position. So we are left with 3 numbers and there is no condition for using that 3 numbers in between. We can do it as we please. So 3 numbers available. How many positions available? 2 positions. So that can be filled up as 3p2 ways. So the result is going to be 1 into 3p2 into 3. And the result is 18. A 4-digit number is formed using 4 of the 8 digits. No digit can be used more than once. So the general condition is we have to make a 4-digit number and we have 8 digits available. So the first math is there are no restrictions. That means we can take any 4 digits from those 8 digits. So that's simple. In how many ways we can do it? We can do it in 8p4 ways. 1680. The number is odd. The number is odd. So at first you have to find out how many odd numbers are there. 1, 2, 3, 4. So 4 odd numbers are available. So that means in last digit, from 4 odd numbers, you can pick 1 odd number because the whole number has to be an odd number. All right. So within this 8 numbers, we have already used 1 number and we are left with 7 numbers. And from that 7 numbers, we have to pick 3 numbers. Why? Because the number has to be a 4 digits number. 4 digits number. And it also has to be an even number. So from 4 odd number, we have to pick 1, which can be done in 4p1 ways. And after using that 1 number, we are left with 7 numbers. We can use 7 numbers. We have 7 numbers available to use. So from that 7 numbers, we will pick 3. And in how many ways we can do it? We can do it in 7p3 ways. The result is going to be, we're doing 7b. The result is going to be 840. Okay, fine. The number is greater than 6,000. Question C. So 6,000. So the first digit has to be either 6, 7, or 8. The number has to be greater than 6,000. So the first digit has to be 6, 7, or 8. So from 3 number, we can pick one number in 3p1 ways. And after using that number, we're left with 7 numbers. We have 7 numbers available. We have to pick 3 numbers. 7. The value is going to be 630. So that's easy. D. The number is odd and greater than 6,000. The number is odd and greater than 6,000. Now, that question, it's a little bit difficult. Why? Because we have equal number of odd numbers and even numbers here. 2, 4, 6, 8. 4 even numbers. 1, 3, 5, 7. 4 odd numbers. 6,000. Now, let's consider 6, 4, 3, 1. So that's an odd number. The first position is even number, last position is odd number. And 7, 4, 3, 2. 7, 4, 3, 1. First position is odd number, last position is odd number. So in case of this kind of math, you have to solve the maths in 2 different states. Well, at first we will consider the first digit will be odd and the last digit will also be an odd number. Now, the condition was the number has to be greater than 6,000 and it also has to be an odd number. So as it has to be an odd number and it has to be greater than 6,000, so what we will do here, we will at first fix the first position. In first position, we can only put 7. Why? Because the number has to be greater than 6,000. And so first digit, if we want to put an odd number, that only can be 7 here. Because within 6, 7, and 8, 7 is the only odd numbers. In how many ways we can do it? We can do it in only one way. Because we are having only 7 that we can put as an odd number at the first. Now, let's fill up the last digit with odd number. So now here, as we have already used 7, we cannot use 7 anymore because we can only use one digit once. So how many odd numbers, odd digit left? 1, 3, and 5. So 3 odd digits left. So we can put that here in 3p1 ways. Fine. So we are left with 2 positions. And we're having 6 digits. From the digits, we can pick 2 digits. And how many ways we can do it? We can do it in 6p2 ways. So answer is going to be 1 into 6p2 into 3. 3p1 means 3. So the answer is 7D 90. It's not the complete answer. It's the answer of considering first digit as odd, last digit as odd. Now we will consider even and odd. At the first position, we will put even number. And at the last position, we will put an odd number because the answer has to be an odd number. So let's put even number first. So we can put only here 6 or 8. We can only put 6 or 8. Right, so we can do it in 2p1 ways. And how many odd numbers are there? 4 odd number. So we can put a single odd number in 4p1 ways. And how many positions left? 2 positions left. We can fill that up from 6 digits. So it's going to be 6p2. So the results from here will be 2 into 6p2 into 4. So the answer is 240. Now you have to add both the conditions. You have to add both the results. So the final result is going to be 330. So I think you have understood. So this was a little bit tricky. So when you are solving this math, try to be very clear about the concepts. Try to think about it. Give time to understand it. As long as you are not satisfied, keep thinking about it. Okay. Because in other chapters, whether you talk about solving simultaneous equation, complicated simultaneous equation, which involves one quadratic equation and one linear equation, or topic like trigonometric identity. So those questions are quite simple. You don't have to think much. But permutation combination, it's not like that. You have to think carefully, and you also have to be right in your thinking process. Otherwise, the answer you are going to get, there's high probability of getting the wrong answers because of considering wrong factors. All right. Okay, question 8. In question, a numbers are formed using the digits 3, 5, 6, 8, and 9. No digit can be used more than once. Find how many different 3-digit numbers can be formed. So that's simple. 5p3. So the answer is 60. Numbers using 3 or more digits can be formed. Now, be careful. 3 or more digits can be formed. I mean, you can form numbers of 3 digits or 4 digits or 5 digits. So if you are using 3 digits, you can do it in 5p3 ways. If you want to make numbers having 4 digits, you can do it in 5p4 ways. If you want to make number having 5 digits, you can do it in 5p5 ways. If you add them, the answer is going to be 300. The question was numbers using 3 or more digits can be formed. So that means they're asking how many numbers you can have if you form 3 digits number, 4 digits number, and 5 digits number. Fine. Question 9. And that's the last question of this exercise. Find how many different even 4-digit numbers greater than 2000 can be formed using the digits if no digit may be used more than once. Even 4-digit number. Be careful. The number has to be 4 digits, and also it has to be an even number. In how many ways you can do it? So what we can do here, we can consider the first digit as odd and last digit as even. Okay, so how many odd numbers are there? There are 1, 3, 5, and 7. Now be careful. At odd position, we cannot put 1 as odd number. Why? Because the number has to be greater than 2000. So in the first position, we can use either 3 or 5 or 7. So we have 3 odd digits available from which we can pick 1 digit to put in the first position of the number. So 3 numbers available, we can pick 1 from them. And in how many ways we can do it? We can do it in 3p1 ways. Now even, how many even numbers are there? There are 4 even numbers. From the 4 even numbers, we can pick one in 4p1 ways. Now it has to be a 4-digit number. So 2 positions left. And how many digits left? 6 digits left, because we have used only 2 in the first position and in the last position. So the middle position can be filled up in 6p2 ways. So answer in this section will be 360. Now let's consider even and even. First digit as even number, last digit as even number. How many even numbers are there? 4 even numbers. The first position can be filled up in 4p1 ways. Now, as we have used 1 even number, we are left with 3 even numbers. So from that 3, we can pick 1 even number in 3p1 ways. And how many positions left? 2 positions left in between the first and last digit. And we are having 6 numbers from where we can pick 2 numbers. So that can be done in 6p2 ways. So here the answer is going to be 360 as well. So overall results is 360 plus 360 equals to 7. So that will be the final answer. Okay, fine. So we are done with this. You will understand a little bit of permutation after watching this video. And I'm going to make more videos on this topic, permutation and combination. I'm solving of book questions, solving of Cambridge IGCSE admit questions, and also Cambridge O-level admit questions. And if you have any particular problem, you can write down that comment section. I'll try to make videos on that. So thank you very much. Thank you for watching the video. Allah Hafiz.